Hello, hello dear, how are you?
Yes, I'm good.
Okay, so let us continue the linked list, please.
Okay.
Okay, so this how a single linked list looks like. As we said, the head is always pointing to the first node that we have, and I want to tell you that sometimes they use the linked list to internally build the queues and the stacks. Do you remember the queues and the stacks?
Yes.
Yes, we didn't study nodes at the queues and the stacks. We only studied that we need to use pop or push for the stacks, and we studied that we use enqueue and dequeue for the queues, right? This is for the stacks. But we never know internally how they are built. So sometimes they use linked lists to internally build stacks and queues. Okay. And as I said, one of the benefits that linked list is a dynamic data structure. It doesn't take a lot of memory, okay, compared to the arrays. If you want to insert or delete items from the linked list, it is very fast compared to the arrays. Okay, so now let me go and share with you. We have something called doubly linked list. So this double linked list, this is first node, and this is the second, and this is the third. And this is the tail, and this is the head. The thing here that every node previously in the single linked list contained only one pointer. So it points always to the next item. So here we are having different. We're having two pointers. One point to the previous item, previous node, and one point to the next. So you see here, this is the first node. Here it's pointing to the second, and the second is pointing to the first. So what is the importance of that? Why we need to do that? Why we need to complicate ourselves putting two pointers? We already achieved the same result with one pointer from, as we can see here. The problem is if you actually go, if you loop through the linked list from the first node until you reach the fourth node, you are not able actually to go back. You are not able to loop back through the linked list. So to loop back, they actually created the double linked list. So that is helping once you reach the last linked list here, you are able to loop back. Okay. So in this case, you don't need to know about the code. You need to only know that the double linked list have two pointers instead of one. And the first node is pointing to the second, and the second is pointing to the first. So here we have two pointers, pointer 1 and pointer 2. So first node is pointing to the second node, and the first pointer of the second node is pointing to the node before it, and it's also pointing to the node after it. So you see here two pointers, one to the previous and one to the next. Did I make it clear so far? So this is the type of double linked list. Okay. So what I will show you also what kind of exam question comes. Typically, they somehow focus on the circular linked list. Again, this is the characteristic of the double linked list. We have the node consists of data, pointer to the successor, pointer to the predecessor. So you have pointer to the next and pointer to the previous node. Okay, and the header node points to the first node and the last node. If you are pointing to nothing, so your pointer points to null. Okay. Also, one thing that in this here, if you can look, we are saying that first and last node are directly accessible. So we are able to either loop from the start or loop from the end. So that is one of the characteristics of the double linked list. So traversal can happen from the beginning or from the end. And this cannot, so nodes are able to be traversed in either direction. So this kind of questions, this is a theoretical questions. This is advantage of the double linked list compared to the single. The single can only be accessed in one direction, and it can only be traversed from the start. It cannot be traversed from the end. So double, it means that we are able to access the linked list from here or from the end here. Okay, is it clear? So this is a theoretical part. Other than that, we move to the okay. So the circular linked list, this is how it looks like. So it is the same. The node is the same like the single linked list. It have a data and it have a pointer. And the point or the difference here that this is the last node, and this is the first node. So the last node is linked to the first. So this is how it looks like. So the last node in the single linked list, it is pointing to the tail or to the null. But here, no, it is pointing to the first. Okay, so I will share with you. Okay, so I will share with you first an exam question before we discuss. Yeah, so you see here, this is an exam question. So it's saying that this is a circular linked list. So the head is pointing to the first, and the last is pointing to the last node is pointing to the first. Okay, to the first node, and the head is an external pointer that points to the first node in a circular linked list. 3 operations are performed. We already perform, or we need to perform these 3 operations. A node containing number 30 is inserted at the beginning of the circular linked list. So we need to insert here a node that contains 30. So there is a node that contains 30 here, 30. We need to insert it here to be the first node. The last node is deleted. So the last node here, we need to delete. The first node is deleted from the beginning of the circular list. The first node is deleted. So again, did you understand what I said, or what is the requirement?
You need to delete the node, the last one.
Yes, I need to insert a new node, and I need to delete the last one. And after I inserted the first one, I also need to delete it as a certain requirement. And what he asked here is sketch the diagram showing the resulting circular linked list. So if I insert 30 here, so it means my head need to be pointing to the 30. This is the head. And the head should no longer pointing here. And then my pointer should be pointing here. And this end should no longer point here. It should come to me here. So I inserted already 30. And 30 pointing to 20, 20 pointing to 5, and 5 pointing to 10. So that is, I already put 30 here. Then he said, the last node will be deleted. So I need to delete 10. So by deleting 10, it means that 5 need to be pointing to the first node. So 10 is no longer there. I need to make 5 pointer point to the 30. Is it clear so far or difficult?
Part of clear.
Part of clear. Okay. The last thing is the first node deleted from the beginning of the circle. So I need to delete also the 30. Even the 30 also I need to delete. So he asked me to delete the 30 again. So if I delete the 30, it means that 20 need to become the first again. So, but again, also this was deleted. So it means that the 5 need to point to the 20. And the head need to point again to the 20. So this is the first, this is the second node, and the last. And the last is pointing to the first. Okay, have a look here at the answer, how it should look like. Look at here. Tell me, what did you understand, please?
Not sure. Why is it required to delete it?
You need to raise your voice so I can understand.
Why is it required to delete it?
Why is it required? So they created the linked list because of its ease of inserting and deleting nodes. I would say, imagine that somebody adds something to the cart. He's buying some kind of stuff online from Amazon, and then he added something to the cart, to his cart, and then he thinks that he doesn't need it anymore, so he deleted it. So you cannot say no, we cannot delete it for him. You have to accept that it can be deleted. If you are buying item and then you are at the cashier and then you tell him, I want to, after he scanned it already, you say to him, I don't need it anymore, please return it back. Can you do that? Yes, it is acceptable, and he need to do it for you because you didn't pay yet, right? So this is a kind of structure that can be used in a cashier or a supermarket or a shopping mall. So this is possible. Okay. So every time a customer comes to the cashier with items from the supermarket that he put in his cart, we don't know upfront he will buying 20 items or 30 items. So we need to use a dynamic data structure because every customer will be choosing different number of items. So we need to accommodate the customer items, whatever it is. Am I right?
Yeah.
Okay. And if he decided to delete one and he doesn't want to buy it, then we should obey his request. So you see, you got 3 marks if you do that. So the first node containing the 20, if you do it like that, then you got 1 mark. So sketching, when you're showing 2 nodes, you get a second mark. When you show that your last node is 5 instead of 10, you got this last mark. So again, do I need to repeat again what kind of operation we did here? Okay. Okay, so one of the question, which is part B, outline how the last node of the circular linked list is identified. We identify the last node that it is pointing to the first node. So if we find that a node is pointing to the first node, we know that this is the last node. So have a look at how the answer looks like. So the last, to identify the last node, that its next pointer, it contains the address of the beginning of the list, or is equal the pointer of the head. So because it's, you know, because of this, so this pointer point to the head or point to the first node. By that, we identify that this is the last. So far, okay, acceptable. You need to read the slides again. That will deepen your understanding of the information. Okay, clear? Okay, so sketching is the key here. Now let me go. I need to, one of the few things that is remaining for us, I need to, let me search linked list again. Linked, yeah. I need to share with you how we actually able to insert nodes and how we are able to delete nodes. So again, this is a node that need to be inserted. So this node is new. This is a new node. Previously, this was not there. There was no arrows like that. Okay. Previously, that line was actually pointing. So let me see. This 208 is pointing to. So, okay. Here, the pointer here is actually pointing, this 920 is pointing to here at the moment. And let me see here. This is the last, so it's pointing to null. This is a tail. And here is pointing to this 645. The pointer here is pointing to here. So if I want to say that I don't want this node, new node, to be there, so it means to me that I no longer need to be pointing to 920, which is this address. I need to point to 645. So I need to remove the pointers like that. The arrows need to remove it. So you need to also delete this 920, and you need to write here in the pointer 645. And your arrow should actually point to here. Okay, so by doing so, it means that we are not using this new node anymore. But what I want, if I want to suddenly, instead of me pointing to pointing the lion node to the next node, which is a seal, I want to not to do that. I want to include a new node. So if I want to include a new node, so I need to check where is the pointer. The pointer that was pointing to 645, which is the last, I want to insert something in the middle. So I want to check, okay, what is the address of the new node? It is 920. I need to make my pointer point to 920, and I need to make my arrow point like that. And from 920, I need to point to the last node, 645. So I need to put here 645. And then I need to put the arrow to point like that. So sketching is what is required in the linked list. You need to be able to sketch. You need to be able to add and delete nodes. So far, is it acceptable so far? Did you understand? Did you grab 60% of what I'm saying?
Somewhat, yeah.
Okay, what is difficult? Just, I mean, maybe I'm not able to clear 100% your doubts because that takes time. But I want to understand from your doubts, what is the issue? Why is it difficult?
What is a node used for?
What is a node used for? A node is used to do two things: store data, which is a line in this example, and it it is pointing to the next item in the list. Because we are trying to simulate a static data structure. Again, it's all about the problems that we are facing in the arrays that make us make a complicated data structure like that. Here, consider this is a node. This is another node. This is another node. But your node here only have data. So I am able, do you think that I'm not able to have arrays that got strings inside? I'm able. So I can have pet like that. I can have a student names inside also, an array. So I put a frog here. I put lion here. So this is an array of strings. This is a node, but it is a simple node that doesn't have a pointer. Why? Because the place in the memory, it is reserved after, it's a consecutive space that is, it is reserved one after another. So by only adding one, I'm able to access the next item. But here it is different. I do not reserve the place for the second node when I created the linked list. That's why my node is complicated. It's having two different information. The data, which is similar to this, and the pointer. Here we don't have pointers. But here in the linked list, we have pointers. So that's what this is a node. Now you understand what is a node?
Yes.
But it is a heavy topic.
Yeah, it's a little confusing. So this is different from pseudocode. Like you have to draw a diagram for this.
Yes, only diagrams at the moment, yes. So only sketching diagrams like that. They don't ask you to write any code for the pseudocode, specifically for this requirement that you give to me. Okay? So please now have a look. Yeah. So if I want to, so that's why I'm telling you the importance or the beauty of a linked list is that you are able to delete items very easy. So, okay. Previously, you was having this node. You have, in the start, you have 1, 2, 3, 4. And then they ask you to delete this node. So previously, give me a second, please. I would bring the initial node here. Let me copy it like that for us to be able to see when we delete. Okay, I try to make it smaller here. So initial state, it's initial state was having this kind of linked list. It have 4 nodes. Then they ask us to delete that node. So if we want to delete it, means that I would look at the previous pointer. So 208 is pointing to what? To this node. So this is the previous pointer. I need to change this previous pointer not to point anymore to 208. So I need to make it point to what? So I need, if I want to delete that, I need to look at this pointer. This pointer is pointing to what? 645. Where is 645? Here. If I want to link this and this means that this pointer no need to look at here. So 208 no need to point to 208 here anymore. I want to delete that. So to delete it, I want to make my pointer point to here, which means I need to copy this 645 instead of 208. By doing so, again, sorry, I'm listening.
No, I was just saying, okay.
So it is as simple as that. Just look at the address here, and then you need to draw an arrow. Important to draw an arrow, and to not to present that anymore. Even if you want to do it like in the exam question just now, you look, he asked you to do 3 steps of insertion and deletion. So even if you do, you draw 3 diagrams until you reach the final state, then it's also fine. If he asks me, okay, after he delete, he want to insert another node at the end. So if he want to insert another node that have 800 like that, and it have a duck here, and then this will be the, sorry again?
I was just saying yes.
So this will be my null, because null is, it is the last node. The last node point to null if it is a single linked list. Okay, so if I would like to look here, so this is the last, I want to make this the last. So it means that I need to link this to here. So I need to make an arrow like that. This is the first step. So the second step here, this is null pointer pointing to nothing, because there is nothing after that. But now we have something. So I need to take this address and put it here. So now this is no longer the last node. This is the last node. This is the tail, actually. So now do you understand? I'm able to delete, I'm able to add. And you only need to know how to sketch that.
Okay.
Okay, that's good.
I don't need to write a code for this. I just need to sketch the diagram.
Exactly. You don't need to do any coding here. This is theoretical part. If I am in your position, after I finish my class and I pass you all the slides, I have a section for all the exam questions. Go through all of them. You will be able to catch and get the theoretical parts, because you have the exam question and the answer, exam question and answer. So memorize that as much as you can. Whatever you can grab from the collections, 1D arrays, 2D arrays, code that we do before, it's also good. Okay, they will ask you about why the stack is different from the queue. This is all theoretical questions. If you can manage that, that will get you marks. You are collecting marks. So at least grab that. Okay? Okay, that's good.
Yeah.
I still have a few things remaining. Please bear with me. So yesterday we talked about trees. I would like to discuss with you the trees one more time. And not only that, I would like to see with you what kind of exam questions that come with the trees. So here is the trees. Now, I would like to discuss the trees from a different perspective here. Have a look at me. And don't look at this now, but look at these numbers. Sometimes, although not many times we can see it, but sometimes they say, so he will give you these numbers. He will tell you, draw a tree from this number. The binary search tree is called binary search tree, is used to actually minimize the amount or the time that we search in a list. If I want to find an item very fast, instead of, if I'm having a list of numbers, if I search every single number, this is the worst case. I need smart ways to search only half of the numbers. So how we can do that? Please have a look here. This is 50. I will show you now how we can actually build a tree that if we search it, we can search it very fast. So the first number is 50. We call that the root. Okay, so he will give you a number and tell you build the tree from it. The first number will go for the root. Now, okay, we need to make a mark like that and say every number that is bigger than 50 will be on the right side. We have right and we have left. So we are, every item that come here, so sorry, we really need to close and open again. Can you? Or we have only 10 minutes with us. Do you have anything?
I have another class after this.
So, okay, can I have 10 minutes with you?
Yes, yes.
Okay, so let me then say this with you. So we have a left side and right side. Every item that I'm going to put here is called the leaf. And each leaf, I'm allowed to put 2 items under it, only 2 items under it. Okay, so have a look here. See, this is the numbers. I put 50 here. 17 is bigger than 50 or less than 50?
It's less than.
So I need to put it on the left.
Yeah.
Less than 50 is put on the left. Okay, now 12 is less than 50 or bigger than 50?
12 is less than 50.
Okay, so we come here. So it means that we need to be on the left side. For 17, bigger than 17 will be on the right. Less than 17 will be on the left. So under this leaf, we have 2 leaves, like that. So I put 12 where?
You put it on the left again.
Okay, yes, correct. So I have 19. Bigger than 50 or less?
Sorry, 19.
Yes.
It's
Less. Okay. Less than 17 or bigger?
It's less than 17.
No, who said
Sorry,
19?
it's bigger.
Okay, yeah. Okay, so we are bigger, so we become on the right. Left, smaller, right, bigger. Okay, so now 21. I'm bigger or less than 50?
71? 21.
Yes, 21.
It's bigger than 17.
Okay, and it's bigger than 21? Bigger than 19, sorry, or smaller? Here.
It's bigger than 19, so we'll be on the right.
Yes. So if I have 72, bigger than 50 or less than 50? 72. 72, 72. 72. Bigger or less? Here, 50. Bigger than 50. Bigger than 50, right? We are here, right? Okay. So now we have 54. Bigger than 72 or bigger than 50 or less than 50? So we here or here? 54.
It's bigger than 50.
So it is on the right. So in 72, here, we have 2 leaves like that. So 54 is bigger than 72 or less than 72?
54 is less than 72.
So we put it on the left. So here bigger than 72, here less than 72. Now, 79, bigger than 50 or less than 50? 79.
79 is bigger, so it'll be on the right.
Okay, so 79 bigger than 72, am I right, or less?
79 is bigger than 72.
So we put it on the right. So that's why, that is how we list a binary tree. So as we said, so what they do here is that they use a binary tree to actually search half of the list. So they always do this comparison. If I'm searching a number that is 21, I will always say 50 or bigger than 50 or less than 50. So less than 50, so I know, so it means that when I go this way, it means that I already cut almost half of the numbers. I no need to search. I need to do if statement comparing 21 to all these numbers, because I already cut my numbers into halves. So if I say 21 is bigger than 17 or less than 17? Is bigger. So I no need to search this side anymore. I need to keep searching here. So by doing a selective and smart if statements, I'm able to loop through a list of numbers, but not all of them. I only do certain if statement, and I'm able to reach my target very fast. So at the end, even if you don't understand what I'm saying, binary search tree is used to save time in searching numbers. Can you do it like that? Can you understand it like that? This is a theoretical. Binary search tree can help you save time in searching numbers or even alphabets. So he can give you, instead of numbers like that, alphabets, ABC. So ABC is actually also numbers. How? So this is maybe 1, 2, 3, D is number 4, and Z is number 26. So you are able to convert them into numbers. And then you are able to list them also based on that. So one of the exam questions that we can see is actually, okay, he is telling here, can you look? Outline why a binary tree would be a good choice for a data structure maintaining an address book. So he's telling why I need to make an address book using a binary tree. So an address book, you need to save addresses, right? So, but this can be ordered alphabetically. So A, B, C, D, and so on, okay? Which also can be converted to 1, 2, 3. So binary tree actually can save me a lot of time. So it is time efficient, especially in searching and traversing when searching for a contact in an address book. Okay. And again, contacts can be listed in alphabetical order, and it's fast sorting. We are able to sort things very fast, and I'm able to actually find what I'm searching for very fast. Because when I'm searching, I am searching half of my list. I don't need to go through all the alphabetics to be able to reach what I'm searching for. Okay, so this is a kind of question that you might get. This is theoretical part. After the class, really read it. Okay, and then I would also I search with you. I search with you actually a few possibility of exam questions. Not only that, this is the disadvantages and advantages of a binary tree. Please, I have to explain to you one more thing before this. So you need to have a look at this. And this is an exam question. And this is using alphabets. I want you to see how the question and the answer here. Okay? And the point here that I explained to you yesterday about 3 types of traversal. So if you want to go through a binary tree, there is 3 methods. One called post order, one called pre-order, one called in order. Have a look at them and compare them. I brought you this image, which is different from yesterday. Yesterday, I show you that image, and I felt maybe it's not the best. But so let me share with you here. So you see here, I start with, if I say that I want to loop through the binary tree using the post order, it means that I need to go from the leaves at the bottom. 1, 2, 3, 4, 5. This is the root node. So I need to start with the left. I need to go to the right. And the final thing is the root. So left, right, root. Left, right, root. This is the post order. 1, 2, 3, 4, 5. Pre-order. So you have to memorize it. So pre-order works from the root. You start with the root first. 1, 2, 3, 4, 5. So root, left, right. Root, left, right. Okay, now the in order, memorize it. So then he goes from the bottom. He go from the left, 1, 2, 3, and then root, and then right. So he go left, root, right, but he go in a different way. In order is very popular in address books. So if you want to organize something in an address books or a contact list, then you need to use in order. That help you